the pace of change has increased. Spring Boot 1 was API stable for, I think, 7 years. Like no backwards incompatible change. 7 years. And now it's, I think, every 3 months. That's not similar, in terms of pace. And so if I'm, go again to one of these large banking customers and I have 20 or 30,000 applications written on that framework, that's a significant pile of work I have to undertake at a much higher frequency than I used to.
This is DevOps Paradox, episode number 301, exploring OpenRewrite and the future of code modernization. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick.
On today's show, we have Jonathan Schneider on from Moderne. Did I even get that close?
You did. You did. That's exactly right.
Moderne. But in case you can't say that, then the name OpenRewrite might sound more familiar. Jonathan, how are you doing today?
Doing well. How about yourself?
Good. Now, for people that don't know what OpenRewrite is, and we'll talk about Moderne later, along with a pretty cool event that's coming up in May of 2025 in beautiful Miami, Florida. Now, let me tell you before we even get there, Miami in May is great because all the spring breaks are over. Colleges might just be now getting out. So when it's happening, it's like the week to not have everybody on your beach.
It's warm enough you can get in the ocean and still feel comfortable. It's great.
Everything we talk about today, you can learn more about coming up in May. But what is OpenRewrite, in case people haven't heard of it yet?
OpenRewrite is a large-scale refactoring, software refactoring solution. And the main pillars of use cases here are application modernization, which encompasses language level updates, framework version updates, things of that sort. Security vulnerability repair is another one. Code quality repair of the sort of things you'd find with like a Sonar cube, like fixing those, is also another one. So in general, anything that you need to change in your code, but not just in one place, but potentially across many, many repositories. That's what it's for.
Now, what languages does it work with?
It started out and is still strongest in the JVM ecosystem. So in Java, we expanded from there into YAML, XML, properties, Terraform HCL, et cetera. So all the kind of infrastructure as code stuff. More recently added parsers for JavaScript, Python, C#, and we do have a parser for COBOL, copybooks, JCL, and about 31 related COS technologies as well. So kind of broad coverage of, I hope some of the most frequently used languages, at least, not all of them.
Working with Java, now people that listen know that I work with the Jenkins project. The Jenkins project makes strong use of OpenRewrite. So thank you, number one. But how did OpenRewrite even come about? What's its origin story? Did it come from Krypton, or was it bitten by a spider? I don't know which
that's right.
You choose to live in.
It came from a special pressure cooker, which was Netflix engineering tools. About 10 years ago, I was working on engineering tools. At that time, Netflix had a fairly small number of engineers, around 600, 700, something of that sort of thing.
Pause. Small set of engineers, 600 to 700. Now, in a lot of places...
This is relative to Facebook, about, which is 15,000 or something at the same time. So it's... But right. I see what you mean.
Yeah,
because it can be a lot depending on the organization.
Yeah, because to me, 600 or 700 is bigger than most companies I've ever worked for. So that's just engineering alone.
That's
okay.
True.
Continue.
That's fair.
Sorry.
That's fair, yeah. So no worries. Yeah. So Netflix, at the time, in addition to being one of the progenitors of microservices, there's 20, 30,000 microservices, also had what they called this freedom and responsibility culture, which basically, for the sake of this conversation, means that central teams like ourselves, like, build tools or security teams couldn't impose constraints on what product engineers did. And so at the same time, we were responsible for, to some extent, helping the organization move forward from Java 6 to 7 and try to kill off this logging library that we didn't want to maintain anymore. And so, other sorts of things in the code en masse. But we couldn't say on a particular day, if you're not there yet, we're going to break your build. We're just going to, turn on some gate and, you're not going to be able to build anymore, because that would be a violation of that freedom and responsibility culture. And so confronted with this problem of how do we get the organization to move forward, I started, I know, in the same position that I think a lot of people do, which is trying to provide context to product teams of where they are right now. So kind of like early internal developer portal, IDP sort of stuff, like dashboards and materials that would help folks understand where they were relative to the organizational goals. And we did workshops and we, tried to help people individually. And it just seemed like no matter what we did, it resulted in approximately no action. People wouldn't do anything. And so as I would talk to different engineers and ask the question, what could I do that would make you move forward on this company-wide initiative? They would say, do it for me. Otherwise, I got something else to do. It was kind of it was somewhat sarcastic, but the sort of root of what I always heard. And so that's where this sort of automation had to come about.
It's interesting that you use the word automation. I mean, I see it as automation, but also I don't see it as automation.
Yeah.
To me, it's almost like a really extremely smart and purpose-built grep for something, or said awk and grep all coming together just in a nice little, and the phrasing that's used within the OpenRewrite project is recipes.
That's right.
Which makes sense. And you can compose recipes together to have, you don't call it a meal, but that's the way I think about it, is I can do a whole swath of things. I don't have to do everything little by little.
That's right. And I'll be honest, we gave find and replace simple sed awk grep a pretty fair shake, and, attempted to do that logging library migration I was mentioning exclusively with that. It got very difficult. Obviously, the more you get to a point where it's crossing multiple lines and you've got nested method calls and so forth, and it's just too hard to make the pattern fit. Moving up to abstract syntax tree level is kind of the next level. You go up from the text of code, you go up to abstract syntax tree, which is the first thing a compiler does. It tokenizes and builds a tree out of the syntax that it's seen to reason about it. That level wasn't sufficient either, because while I could accurately identify a method call called info, I couldn't tell you whether the logger field that info method was being called on was, in fact, a blitz4j logger internally, or if it was an SL4j logger, a log4j logger, because the actual method signatures can look very similar. And so that's the abstract syntax tree wound up being surprisingly insufficient for even the simple transformations we were trying to do.
Aren't ASTs just supposed to be the answer to everything?
It's certainly an improvement from text. It's definitely a step up in understanding. But yeah, it's in many ways still a poor representation of what's in that code.
So what was the next big step? Because you found that, okay, basic search and replace, right? That's where you started. It's like, how can we safely do that?
Yep.
Right. And then you said, okay, how much further can we go with AST?
Yep.
Then you hit the brick wall again.
That's right.
What made you want to press through that wall?
Well, that specific problem, and it was a silly problem. The first one is just trying to kill off this internal logging library we called blitz4j. It looked very similar to SL4j, slightly different parameterization, slightly different order of arguments, but pretty much the same otherwise. And we didn't want to maintain this anymore. Why? Why? There's no reason to have a proprietary logging library like that. We just couldn't do it. I couldn't do it with find and replace, and I couldn't do it with AST only. Trying to pursue the minimum necessary information in this information representation to accomplish this change, I layered in one layer of what we call type attribution, which is the information about what these symbols represent. So, for example, when I see a logger field name or variable name, I need to know what type that logger represents. And what I didn't need quite yet was to say, what are all of its super interfaces and super classes and so forth, all the way up to type hierarchy. I just needed to know kind of immediately what the direct type was. And so how do you get that kind of information? You could go a couple different ways. I could build an AST from tree sitter, from Antilar, something like that takes a text of code and turns it into an abstract syntax tree, and then try to create the algorithm that added the symbolic information. Like when I see this field, what type is it? Or I could decide to just programmatically exercise the language compiler itself. So the Java compiler is written in Java. It's just Java library able to ultimately, and I could try to guide it through its first few phases of compilation, through producing an AST, through going and solving for all the symbols on that AST, pause it, and then pull all the information out of that internal representation in the compiler and act on that. And that's the path I chose because I didn't want to reinvent all the symbol solving that's inherent to the compiler. I thought that's a complex problem in its own right, and it is.
So it sounds like you were able to do that in maybe a weekend. That's what it feels like, right? That's all it took.
Close. This is one of these Christmas projects that I often do. It was one of these late December, early January, everybody's kind of out and you kind of get time to get heads down and just soar for a while. And a lot of the basic elements of OpenRewrite were created then, over that Christmas in, I think, 2016.
That still wasn't OpenRewrite. That was still, you were solving for that problem within Netflix. How did that come out of Netflix to become OpenRewrite?
Luckily, Netflix was very permissive about open sourcing tools internally because, and they were famous for this with Eureka and Ribbon and Hystrix and, the kind of the whole Netflix OSS stack of microservice development that was popularized. This was true for our build tool plugins as well, the Nebula suite and the Gradle plugins, Spinnaker, continuous delivery solution. And so OpenRewrite from the beginning was just Apache license. The feeling was that we're not done when we're done with Blitz4j, that there's going to be work like this that is going to keep coming up over and over and over and over and over again. And so it was worth investing in.
My favorite was Hystrix. I'll just leave it there. That was feature flags before feature flags was cool.
Yeah. In many ways. Yeah. Super cool visualizations of that internally. At some point, I kind of sense that this problem is very broad. It's not just Blitz4j to SL4j. We're doing Java version updates that has a lot of different steps to it. There's just any modernization effort we want to pursue could be solved with something like these programmatic recipes. And so I remember going to a skip level meeting with the VP of engineering, Yuri Israelevsky at the time. He's since moved on, I think, to ClickHouse. He heads product over at ClickHouse these days. But Yuri just, I was ready to advocate for building a team around OpenRewrite or, this mass refactoring thing inside of Netflix. And his immediate answer, and wisely, was just no. It just felt like it was too big of a problem to live inside a company like Netflix. I think that's why Uber, when they worked on Piranha for refactoring, a little bit different approach, but similar goal. Google working on Refaster, Facebook working on Code Mods or JS CodeShift. They all kind of got so far and then they gave up on those efforts because it could really take on a life of its own inside a company like that.
And thankfully for you, they did stop because that gave you the ability to go ahead and keep going with OpenRewrite.
It was one step in a journey that eventually led to the founding of Moderne, and it wasn't immediate. So I didn't take this courageous step out of Netflix and say, okay, well, I'm going to go do this as a separate company. I actually took a detour and went to the Spring team and founded a project called Micrometer and started working on Spinnaker. And so just kind of in a different space of the developer journey altogether. And it was there that I was working with Moderne co-founder Olga Kunzic on Spinnaker in large enterprise environments, trying to teach advanced continuous delivery, automated canary analysis, this sort of thing. And I kept seeing the same problem. They would say, well, I'd love to do automated canary analysis, but talk to me in a year when I'm done moving Spring Boot 1 to 2 or, Java 6 to 7 or whatever the emergency of the day was. And we just, what was sort of startling is how repeatable the problem was across. It didn't matter what vertical, whether it's financial services, retail, whatever, or size of company. And it's really because we're all building on the same third-party and OSS substrate to some extent. We're selecting, from the same component bins, and that stuff evolves at its own rate. And so it's either you keep up or potentially your app's not functional at some point, or it's got some sort of operational issue or security issue later on.
Well, the story that you just told there, Spring Boot 1 to 2, or thinking JUnit 3 to 4 to now, in these world, 5. Or even worse, Java 11 to Java 17 to Java 21 and soon to be Java 25. Right? Just to keep LTSs. Don't take the ones in between. Stay with the LTSs.
Stay with the LTSs.
just do that. And we can talk about Java a lot because Victor isn't here right now, because he would just be telling me, well, Java's not a real language. Yeah, it's not a real language. It's
and as far as I can tell, Victor's not a real person. So see, that works out, right?
Yeah, it's okay. I'll take advantage of that while he's not here.
Yeah, exactly.
But let's go back to my JUnit example, right? JUnit 3 to JUnit 4 is not trivial.
That's right.
And JUnit 4 to JUnit 5 isn't trivial, but it's not trivial in a completely different way.
That's right.
Than 3 to 4. But you can't get 3 to 5 without going through 4.
That's right.
Is that just a downside? Okay, we've been happy with Java. Let's bash on Java. Is that just the way it is? We just have to deal with it and go through every wall to get to where we want to go. Is there no way to shortcut? I mean, I guess sometimes there's a way to shortcut it, but I've never seen it consistent.
That you have to take these incremental steps from 3 to 4 before you go.
Pretty much, you always have to go incrementally. Yeah. Which, I mean, sometimes you can make a jump. Like I said, that's not all the time. Are people trying to solve for the jumps? Here's what I think. I'll put in my 2 cents on this. People have been they're still running Java 6, and they want to go straight to Java 21.
Yeah.
You're not going to do that in one hop. Realistically. What do you think? Depends?
I think it depends.
Okay.
I think it depends.
So what would be the depend good and depend bad? Like if I want to change if I want to go to streams in one pass from 6 to 21, can I do that? Could I rewrite everything?
Well, I wouldn't recommend that anyway, but
No,
I know it's a bit of a,
it's very contrived.
Example.
Yes.
Yeah. I was talking to a banking executive a couple months ago that he was talking about wanting to fix one particular vulnerability that regulators were hounding him on. And he said, I just need to update the version of this thing. And I thought, well, this seems fairly easy. It's got 3,000 applications, but nevertheless. But the catch here is that the minimum fix version of this dependency that fixes the vulnerability has a baseline of Java 17, and I'm on 8. I thought, okay, slightly worse, but we have a Java 8 to 17 recipe. We can do that. He said, but the additional rub is that all 3,000 of these apps are running on WebSphere with the maximum version of Java 8 because they're only entitled to a specific version of WebSphere, whose maximum version is Java 8. And so to even move them to 17, I have to move all these apps from WebSphere to Tomcat, which means replatforming entirely. And so then the question becomes, okay, well, I mean, this is getting like scarier by the second, right? But I thought, well, what are we talking about here? This is running on WebSphere. Like, are there a bunch of EJBs? Is it like what, Nope, just straight servlets. Not a single EJB, just straight up servlets. So it could just as easily be running on Tomcat. It's just, they just happen to be running on WebSphere. And so there are circumstances like that, and sometimes across substantial business units where there's not a lot that needs to change, So the one thing that did need to change in addition to the like regular Java 8 to 17 sort of move was that it was using WebSphere MQ and needed to move to something like RabbitMQ. But even then, like I can definitely execute that with recipes. So it's would require testing, of course, but the programmatic changes can definitely be done. So it very much depends on the technologies. How much of the technology surface area are you using, I think?
Well, I think the thing you peeled back there is a tale as old as time. We can make a code change, but just making the code change doesn't mean that's all that's got to be done. Because, as you said, they would have to replatform from WebSphere to fill in the blank. There was probably other transitives that came along that made things that you didn't even call out. That's sort of I could say that's part of our living in the JVM ecosystem, but dealing with transitives, we're used to it, but I think it's even worse in JavaScript land.
Yeah. Well, I mean, yeah, it used to be complete class path isolation or componentization there, and now it's. I mean, that has its own downsides, but not anymore. Now there's conflict resolution. So welcome to our hell, where everyone ultimately winds up sooner or later. But yeah, it's definitely nasty, I think, in its own way in different ecosystems. I think we focus a lot of our time on the social engineering aspects, which is what you're kind of getting into here. If you're new to the space of mass scale auto remediation, you're sort of starry-eyed, new to this. Maybe you're a new company in this, or you're just kind of ideating on how would I do migration engineering. It's easy to think I need automation to make the code change, and then I need some system to do mass pull request issuance. Once provided with that system to do mass pull requests, kind of build it and they will come, right? Like issue the pull requests and they'll be received on the other side. At the outset of this effort at Netflix, I found that not to be true. I think people perceive pull requests coming from external teams, often like unwelcome advice coming from an in-law. Sorry for in-laws out there, but it's like it could be great advice, but it feels unwelcome, and so you just look for a reason to reject it. And curiously, so we call that push-based change, when a central team is trying to push change horizontally across the whole business at once. That does not tend to yield high merge rates. The number we've seen time and time again, I don't know why this is the number, but is around 30%. You'll get about 30% out of that push-based mass pull request issuance. And then there's the other side of this, which is, so you have to create mechanisms that are pull-based. In other words, provide enough context for a team to see that there's a change to be done, and then provide the exact same automation that would have been used to create that pull request, but put the button to create the pull request in the product team's hands, and the success rate is much higher. It's just a human nature sort of social engineering problem of like, if I open the change, I'm more likely to merge it.
That just seems so bizarre to me. But again, take a look at every open source project and see how many open PRs there are, and I will tell you how good that project is. Because if there's enough and they're sort of flowing reasonably, then it's probably okay. But if it's stacked up and you've got PRs setting from 3 years ago, is that a project you really want to be using? Or is that a component that you want to be using?
It certainly discourages some degree of contribution, right? Because, yeah, it's hard to be perfect on that too as an open source. Depends on how many resources you have. But yeah, you're right. It can be difficult if you don't keep up with it.
So let's talk about the recipes real quick. Or maybe not real quick, because that's the sort of the real magic to this. I think, because and again, Moderne has a different thing. We'll talk a little bit more about that later. But just if I was wanting to use, like if I'm wanting to do a quick start, I've got a little open source project and I want to use OpenRewrite, and I'm wanting to move from, let's use 2 recipes. I want to move from 8 to 17, Java 8 to 17, and I'm also wanting to change all of my JUnit tests, I'll use that again, from 3 to 4, right? Because I'm just old with this. And there might be Spring Boot in there too or something, right? Just one of the frameworks. Do I have to chase down do I have to write all that? What do I do? I mean, it's like, how do I get started? Where do I even start? How do I even start thinking about it?
If you look at docs.openrewrite.org, you'll see the reference for the available recipe catalog, which is, recipes are programs that do individual units of transformation. And those could be as big as Java 8 to 17, or it could be as small as change just this method name on a particular type or something like that. So, there's thousands of these recipes out there. The ones you mentioned, Java 8 to 17, JUnit 3 to 4, and Spring Boot migrations are all available out there in one form or another. So you just select the recipe, you configure, if you're doing this on one repo, you apply a Maven plugin or a Gradle plugin to your project, you configure it with the recipe, and then you run a build tool command, a Maven or Gradle command that runs the recipe. It will produce patch files or diffs for all the changes, and then you can apply those to the repository. And so it's basically pre-staged the changes for you. That's the goal. And then from that point, you choose to commit them or not.
So the interesting thing in that, you sort of glossed over it, is just renaming a method. Like let's say I messed up and I didn't camel case correctly just because I did something silly. there's not necessarily a recipe for that method, but there are generic recipes that are easy to configure that I can just say from to. Those aren't the
That's
right
exactly right.
phrases, but it's something in that.
Yeah.
Because we did that on some projects within the Jenkins project to where we just needed to do a couple of small things like that. But it's like, okay, I don't need a big recipe like standalone. It's like there's already just some utilities like a little screwdriver or a little hammer, right? That will do the one specific thing without me having to write something. And that's the key thing is when I've looked at some of the recipes, I'm head scratching for a very long time, trying to understand what some of, like talking about the Spring Boot changes, right? What's really going on, because those are complex.
Right.
But then we're also talking about you don't have to nickel and dime each one of those recipes. You can stack recipes together.
That's right.
So it's like, okay, again, the way I think normally is, okay, let me do this one thing, then I'll go do this other thing, then I'll go do this other thing, and however many other little things I need to do. It's like, okay, I might do that another pass one more time. It's like, okay, yeah, that worked. Then the great thing, I called it a menu. I don't remember what you got. It's a composition of all those recipes come together, and then you just apply that composition.
That's right.
And it goes off and does all the things, which is super cool.
That's right. And what I like about stacking them compositionally like that is you can choose to take the top level thing, like Java 8 to 17, and just apply it all at once. Or if understanding all the constituent changes in that is overwhelming to you, you can look at one of the sub recipes, and just apply that. So it'll be fewer changes for you to think about at once, and you get those through, and then you go on and do the next set of changes. We see that very commonly be an accelerant to pull-based change to actually get things through, is how much, it really depends on the risk tolerance of the business unit receiving the change. If I'm trying to get everybody to Spring Boot 3.3, well, to get to 3.3, you have to get to 3.2, which means you have to get to 3.1, which means you have to get to 3.0, which means you have to get to Java 17, which means you have to get to 11, which means you get, And so do I ask them to do it all at once? If the app is, say, like on Spring Boot 2.4 Java 8, no, in many cases, it's easier for them to just get to Java 17 first and stay on Spring Boot 2.4. Get that to production, rest with it a little bit, be comfortable with the operationalization of that, come back and rerun the recipe that includes Java 17, which now won't do anything because it's already been done, and do the rest of the change. And oftentimes it gets broken down even further than that. I think a really great example of this is organizations they use Maven, say, and they don't have Maven wrappers checked into all their repositories. Now, whether you can even move to Java 17 entirely depends on what CI server the build winds up on, because if the CI server has a particular version of Maven on its path variable, that version is not Maven 3.3 or whatever it is that you can develop with Java 17, you could change all the code to Java 17. It's going to break when it lands in CI. So a good first step is let's just get Maven wrapper 3.4, 3.5 or whatever checked in everywhere. None of the code changed. None of the runtime changed. No risk. If it built yesterday, it builds today. But let's just get that done. That gets me used to the idea of mass committing something. And sometimes that has organizational dynamics. How do I attach a Jira issue to it, or GitHub issues issue to it, or how do I get approvers on mass, and so you kind of work through that process. Then you go back and you do the slightly more complicated thing. And all the while you're kind of building up trust in this muscle of, oh yeah, I can actually do things horizontally across my whole team as opposed to just one at a time.
So 2 things out of that. Number 1, yes, kids, there was a time before Maven wrapper. It was a bad time.
That still exists.
It does still exist.
In many places.
And number 2, do one thing at a time until you trust it.
Yeah.
And then keep stack. The one thing I hadn't thought about is, okay, maybe I start with my composition from day one, but the only thing in the composition day one is the one thing. Right? And then when I'm ready to add the next thing,
sure,
then I just tack it on the bottom. And sequence does matter, by the way. It is processed top to bottom.
Absolutely.
But then you were talking about to all the places. Now, it seems like I would have to have all the repos on my machine in order to do that, right? But I have a feeling that's where Moderne starts to come into play.
That's true. And maybe I'm kind of confusing these two a bit. If we go back to the OpenRewrite experience before, it was add a build tool plug into the repository, run a build tool command, of course, how you configure the build tool is dependent on whether it's Maven or Gradle, and then you have to run that build with a specific version of Java, say, or, depending on the version of the project and its starting point. So it gets very complicated. Yeah, Moderne is meant to just exercise that same recipe, but across a set of repositories and potentially hundreds, thousands, tens of thousands of them. There's one other main distinction there, which is in OpenRewrite, basically what's happening under the covers when you run a recipe is it's parsing the code into that what we call the lossless semantic tree. It's AST plus all that type attribution information we were talking about earlier, plus all the formatting of the original project is important as well to preserve style. But we keep all of that in memory. And then the recipe runs and it makes changes to that tree or extracts data from that lossless semantic tree. And then those changes get materialized back as source code to make the change. The process of bringing code from its textual representation on disk to lossless semantic tree in memory is by far the most time and resource intensive process of the whole recipe run. The recipe run itself is negligible in comparison. One of the differentiators really between OpenRewrite and Moderne is that those lossless semantic trees that are in memory in OpenRewrite open source, we are able to serialize to disk in the form of artifacts in Moderne. And so then you're able to basically, in sort of an offline process, create LST artifacts for whole business units and then pull them and operate on them as whole business units as opposed to on a per repository basis.
Which is good if you're trying to basically have the easy button. We'll give Staples their credit on that. One of the greatest marketing campaigns ever
Great
created
marketing.
was the easy button, right?
Yeah.
That's Moderne.
Why didn't we think of that?
Yeah. Well, but I guess the way I think about it is OpenRewrite is the battery and the clips and the button itself and the casing and everything else. And where Moderne is just here's the button, press the button. Not, I'm extrapolating too far.
It's all the pieces. Yeah.
It's all the pieces
or
put
some
together.
of the pieces. Yeah.
Yeah. But again, just OpenRewrite itself, open source, Apache licensed, everything's sweet to go. And it does make a difference. I can speak firsthand on that. Now, getting my head around it at first was, but
I can imagine.
In full disclosure here, Jonathan and I actually met in real life. That doesn't happen very often.
That's right.
We met at the Dallas Java User Group in November of 2024. And we had a chance to talk there, and it's like, oh yeah, we've done this. It was, now we're finally talking here.
Yeah,
it's interesting though. I'm looking at what OpenRewrite is today, and it makes sense. There's a big community around it. It's not just Jonathan writing all these recipes.
Yeah.
In fact, you're probably writing
very few,
less than 5% of them, maybe
far less than that at this point. Yeah.
You're just wrangling, I guess, at this point.
Wrangling. A lot of wrangling.
That's probably, which is more fun, writing the recipes or wrangling? Probably recipes sometimes.
A little bit of both. Yeah.
Each one makes you appreciate the other. Probably.
That's right.
Where's OpenRewrite headed in the next 3 to 5 years? Because if we think about it, Java's been around now we're coming up on 30 years in a year, roughly. Based on what you're seeing, you're still seeing WebSphere with a minimum requirement of Java 11 today
8.
in 2020. Java 8.
Or maximum version. Yeah,
maximum 8 of Java 8. And this is 2025 now. We're not pre-recording this one too early. And I see that as well.
Yeah.
Java's going to be around. Java is the new COBOL. Yeah. I mean, COBOL will probably outlast Java, but that's a different conversation.
Yeah.
How are you going to keep up with this? Because, okay, let's play out this scenario. I'm losing track of when everything comes in, right? So let's say there's a new Spring Boot that's going to come out in a month. How long is it going to take, not you, but the community around it to actually have a recipe to get you up to whatever that next Spring Boot level is?
Well, and maybe this goes to the market in general. And what you can see OpenRewrite is a two-sided marketplace, which is there's recipe producers and there's recipe consumers. And so like any marketplace, it's how do I get the appropriate population in each? Airbnb wouldn't be anything without any houses, nor people willing to rent those houses. And so one interesting dynamic here is that, well, ideally, I want the framework authors, the ones making the break and change, to be the ones that write the recipe that fix their downstream consumers. After all, they're the ones with the most context in their mind of why they made the change and what the correlated thing was supposed to be. They document this oftentimes in migration guides. Why not just write the recipe along with the migration guide and really help me get there? I can try to promote a altruistic view of this, like, you should, as a framework author, provide this recipe so that your downstream consumer has an easier life. But I don't think I have to lean on altruism here, because we work with some of the largest companies in the world. I think 6 of the top banks, 10 banks in the world, a lot of large insurers, some of the largest retailers in the world. What's interesting here is the power dynamic, is that they're customers of Broadcom that owns the Spring Team. They're customers of Red Hat that owns Quarkus. There's customers of Oracle that owns Micronaut, et cetera, et cetera, et cetera. These, most of these large frameworks exist somewhere, fit in some commercial entity. Honestly, let's just be frank. They can put spend at risk back with those entities to say, you're breaking me constantly by using your platform, and I'm sick of it. I'm trying to build features forward for my business. You keep breaking me on the back end. So if you break it, you fix it. I don't expect this stuff to be public a lot, but we've actually seen this in very concrete ways in some of our customers actually putting spend at risk back with those big vendors to say, you owe me recipes, And so I don't feel like I'm not leaning on some sort of like, we all kind of agree that this is the best way to go, but I think that there's actually the right sort of dynamic to be self-reinforcing on this two-sided marketplace.
As a quote-unquote maintainer, I don't like the idea of having to write yet one more line of code. But it makes sense, because if I'm already writing a migration document, why not just, if people want it, it's like the migration document let me restate it. The recipe should be a codified version of the migration document.
That's right. It's codifying your knowledge. Yeah. To be clear, I don't mean to say I expect every framework author to do this in every case. I just think I believe in market forces here. And if you're a proponent of you're a proprietor of a major framework, and there's competing major frameworks, well, I evaluate frameworks as a user on multiple dimensions. One of which is just the pleasure of working with it, how well tested I think it is, how secure I think it is. And I think one of these dimensions I have to consider going forward is how easy is it going to be to keep up with changes in this framework going forward. That's a big reason people didn't select Scala, right? It was actually it was known to be hard to keep up with changes to that over time. It's a reason why people have stayed with Java, because it's relatively easy to keep up with changes going forward, or it has been historically. So I just say I would add it as another decision criteria when selecting a framework that you use.
Like, how well are they going to treat you?
How well are they going to treat you? Yeah. I think you were hinting at something also before that I think is significant and maybe kind of flew under the radar, which is the pace of change has increased. Spring Boot 1 was API stable for, I think, 7 years. Like, no backwards incompatible change. 7 years. And now it's, I think, every 3 months. That's not similar, in terms of pace. And so, if I'm go again to one of these large banking customers and I have 20 or 30,000 applications written on that framework, that's a significant pile of work I have to undertake at a much higher frequency than I used to.
So where does AI come into play in all this? There's AI running underneath all this, right? We've already proven that there's not at this point.
It's kind of in some ways the other way around, but I do think that there is an interesting play here. So first of all, we've seen, the emergence of things like Amazon Q-Code Transformer. Andy Jassy famously announced Amazon Q-Code Transformer saved something like 7,000 years of effort internally. What was in the blog and not in his keynote was actually Amazon Q-Code Transformer is built on top of OpenRewrite. So the engine that's actually doing the work under the cover is OpenRewrite for that big Java migration. It makes it sound like it's AI on top, and there's certainly an AI verification loop on top of it, but the primary engine was a rule-based one. Similarly, Microsoft GitHub Copilot Upgrade Assistant very transparently uses OpenRewrite to do its work. Broadcom Application Advisor very transparently uses OpenRewrite to do its work. IBM Watson Migration Assistant, I believe, uses OpenRewrite to do its work. So the ones that are doing mass change lean back on a rule-based system because the scale of change it can create is, you can't have this potential for hallucination. On the other side of software development, which is net new code authorship, writing out net new code, that potential for hallucination actually is not it's almost a feature, right? It's the things that Copilot suggests are by definition the things that my IDE intention actions were never good at. So they're very complementary. It accelerates my net new recipe development. It accelerates a long-standing trend towards industrialized software production, which started with a general availability of third-party and open source stuff and great IDE tooling. I developed net new code a lot faster. But then it was on the shelf, and how do I maintain it? And that's a problem that we haven't had a sort of industry-wide solution to for a long time. And so I see this like AI code authorship accelerating, putting the gas on net new code authorship. And we really do need to bookend that with how are we maintaining it on the opposite end.
So if people don't care about their old code, they can just have AI write everything. But if they care about the things that's actually making them money, they've got to maintain it. Or do they? That's the tale as old as time as well. It's like, do I really need to maintain something that's 10 years old?
I think there's an old Joel Spolsky article. We're dragging up stuff from the past here, and I think this is almost 20 years old now, but Joel Spolsky, for those maybe newer listeners that don't know, one of the founders or heads of Stack Overflow, he's written some great materials on software engineering over the years. And there's a paragraph somewhere, and I don't remember exactly, maybe we can link to it somewhere on the show notes, but about the cost of a line of debugged code in production. That was great, because it's like you write a line of code, you operate it, you figure out a couple things, you make some changes, maybe it's performance, maybe it's functional. It doesn't happen all at once, right? Code kind of like reaches a functional state over many iterations. So I think it's very difficult to just throw out everything, because it's not just about kind of bang out lines of code. It's what's the cost of a debugged line of code. That takes time.
And then it's the other side of, this is a very prescient point for me right now. At the time of recording, Git 2.48.0.1 is coming soon. Just came out. It broke some things. And of course, I'm a good person on my Mac. I update all my I keep everything updated. And now it broke things. So now I'm having to debug and figure out, okay, do I fix? Do I roll back?
Roll forward.
Well, that's
the
when
way to go.
It is the way to go, but it just hit me about an hour ago. So,
yeah, it's always hurts when it does. I used to have a command, a whole series of tooling. I lost it somewhere along the line called yippee-ki-yay, which is just, you run yippee-ki-yay in the morning, and starts updating a bunch of different types of things, and go get a coffee or whatever, come back, and we'll see if you're in a functional state or not.
But Victor, I don't think you ever have that problem, right?
Which one?
Update broken. All. What is it? YOLO?
Yippee-ki-yay.
Yippee-ki-yay, YOLO, all the above.
I mean, I'm of opinion that actually updating very frequently is the least painful option.
I agree.
Upgrading a single library to the next minor version or patch, and then doing that 1,000 times is infinitely easier than waiting until I need to update 1,000 libraries.
But it is more work.
I don't think it is.
I'm not sure that it is in the long run.
In the long run, it's busy work, but it's not necessarily work, because of course you have all your tests written, right?
Even without tests, right? If I update a single library to the next patch, right, and something goes wrong, I know what's wrong. I mean, I don't know exactly which line is wrong, but I know where to look, right? This is what happened, right? This is what was updated. When multiple things are upgraded at once, I can only scream. That's the only thing I can do. Kind of maybe not the only thing, but that's the first thing I do.
And you do that regularly throughout the process. Yes.
Yeah. Right. I feel that, and we see that in industry often, that what I'm about to say is not only related to upgrades, but in general, kind of, hey, it's too expensive for us to do this today. We're going to do it tomorrow. And then you realize that actually tomorrow is not double expensive, but triple. And then you say, I'm going to do it day after tomorrow. Until you reach the point to say, there is nothing I can do. This mainframe is going to stay here forever.
Inflation is real. So OpenRewrite can be found at openrewrite.org. We talked about Moderne. I'm going to spell it. It's Modern, Modern, with an E on the end. So Moderne,
Yes.
very French,
Yes.
.io, which is it's a SaaS offering that has, it makes, we were talking about doing, so OpenRewrite, if you're just working on a single repository, OpenRewrite is your friend. If you're trying to manage a set of repositories or even a full organization, thinking GitHub organization, you also support GitLab as well, I believe.
GitLab, Bitbucket, a
Bitbucket.
bunch of different things.
All the above.
I've actually seen an organization with 9 distinct version control systems operating at once. And so in that case, we'll operate on all of them.
CVS or
No.
Right.
Well, 6 of them are Bitbucket and 3 of them are GitHub.
Okay.
It's just multiple copies in different network segments.
Which is interesting because if there is a common library that all of those things use, I mean, you could pull it off just using OpenRewrite, but having that visibility to where, okay, I've wired everything in. Now here's everything. Like we were talking about earlier, we want to go through and make sure we don't have anything named. Okay, I'll use this because let's say we're wanting to rename every master to controller, and we're wanting to rename slave to agent, right? Trying to have friendly
I understand
naming.
what you mean.
Being able to do that at not just an organization level, thinking product level, but like my organization level, which includes who knows what. And just having that visibility is like, and again, not automatically putting the PR, although it could, right? Because I could go ahead and just fire those off. But again, maybe it's an engineering manager just go through and it's like, oh, yeah, these are good, these are good, these are good, or whatever it is.
Yeah.
If you're interested in that, you can check out moderne.io. But we're talking about Miami. Victor, do you want to go to Miami? Could you hang out in Miami?
I'm going to Miami in a month.
Okay, well, that's too early. But
And you can come back in May.
you can come back in May. So
What's in May?
Moderne is, you're sponsoring with the help of the team at
Jay Zimmerman at No Fluff Just Stuff.
No Fluff Just Stuff. It's called Code Remix. Even though we're saying Miami, it's actually going to be in, Victor, you might like this. It's actually going to be at the Margarita Hollywood Beach Resort in Hollywood, Florida, which is north of Miami, actually north of Fort Lauderdale. If you can get into Fort Lauderdale, much easier airport to get in and out of than Miami, trust me. If you want to go, there is actually a code that you can use to save $300, and it's not one of our codes. So we're not getting anything on this. It's Moderne 3, the number 3 VIP. It gets $300 off. And this is May 12th through the 14th. And if you've ever been to any of the No Fluff conferences, there's a lot of the common people that you're going to see there. A couple that I saw was Pratik Patel, Josh Long, Venkat. Yeah. You name it, all the names that you're used to. You can check that out at coderemix.ai, not IO, .ai. Why AI? Come on, you're not doing AI here, or are you?
Yeah, well, that's a whole nother subject, and maybe worth like 1 or 2 minutes at the end. There is a little bit there. One more thing about this conference, I think, the way we're trying to organize this, because I'm a developer, I still like hands-on development. You can't pull me away from it. We're doing 3 tracks. So there's a developer track. That's where the Venkat, Josh Long, Baruch, like you said, regular suspects. Also some really new, interesting voices. I mean, I think we're inviting somebody from Patient in Columbia, Missouri that's talking about a really new, interesting language called Rock. That's one I'm really interested in going to. So developer, leader track. So we'll have folks from some of these, the largest banks, retailers in the world talking about how they're doing migration engineering like this and other topics. And then the one I'm kind of most excited about is the hack track, which is going to be going on for 3 days. We're going to have different tables set up with particular tooling and things like to play with. And so what we're asking attendees to do is come with your work laptops too, and like as much stuff on them as possible, and get the security guys or whatever to get over that before you arrive. Come with that stuff and we're going to do things like, so for like recipes, it's like, we're going to write new recipes with you, custom recipes. We're going to apply them. So the idea is like, you come with some stuff and you go home with work done.
Shouldn't people come with private laptops then, instead
Both.
of company laptops with VPNs and all those things that prevent you from doing anything useful?
I want company code. That's the main thing I want, because the goal is to provide as much value. And so I've done a lot of workshops at NFJS conferences, DevNexus, et cetera. And one of the common problems I encounter is like, there'll be people in the audience that say, oh, I wish I had brought my work laptop. I could have done this Java 17 migration on. But so it's like, come with your stuff, get that security guy to approve it, because we want to do like real stuff, not just hypothetical things.
We are not lawyers. We are not advocating that you break any of your corporate policies at all.
Yeah, get approval.
Get approval. But regardless,
get approval.
Clone your repository first, because you don't want the computer connecting to the network.
That's right. And download dependencies.
Download all your dependencies. Just think as if you're going to be on a plane for 12 hours. Actually,
exactly.
72 hours. You're
3
going to be on a flight for 72 hours.
That's right.
You can work.
Yeah.
Think about how much work. I don't know about you. I get probably most of my work done on an airplane. Maybe that's why I'm not getting any work done.
I do.
Because I haven't been on a plane in 3 years or 5 years now.
Guaranteed focus time.
Yes.
Guaranteed focus time. So the one brief bit about AI, I think this is accidental, but because we built up this lossless semantic tree over time with all the information the compiler knows and all this stuff, because we were trying to write recipes to make changes, I think we came into possession of a data source that has information that's below the text of the code. When you can do that across a whole business unit, or it winds up being an ideal tool that you can enable a large language model to use to reason about code and to suggest change in a more accurate way. It's tempting for folks, I think, to say right now, models will get better, they'll get better, they'll get better, they'll get better. I think one of the key problems is that oftentimes they're operating on text or AST. It's just not enough data. It's just not enough information. Back to the original example we talked about at great length about blitz4j to log4j. Knowing that there's a field called logger doesn't tell me whether it's blitz4j or log4j. I need to know what the compiler knows about that field in too many cases. Just last night, I put together what's a model context protocol, or MCP server, that's enabled with a bunch of OpenRewrite recipes that are acting as tools, and bolted that into Claude. And so from Claude desktop client, I can ask a question about how this particular technique is used in thousands of repositories. What it does is it calls the tool, runs all that, collects that all up into, OpenRewrite data table, provides that back to the model, and then it can further reason about what to do with that data. And so I think there's a lot of interesting use cases that are going to come out of this rich data set that we built for migrations or refactoring originally, but didn't anticipate this application.
If it can be a tool for AI, that's going to be based on what you were saying before, AWS, that's basically how they wired it up. It was a tool.
It is.
So
it is.
Just if you're already using tools today, this is just another tool in your tool belt.
It's another tool. Yeah, one of many. Mm-hmm.
Well, all of Jonathan's contact information will be down in the episode description. I'll also have links down to that Spolsky article and the link.
You knew what I was talking about.
I know what you're talking about. I remember it, but I'll have to find it. And also the link off to Code Remix with the code that will save you $300 up until a certain point. If you're listening to this after May 12th, it's over. So sorry. You will have missed out in Hollywood, Florida at Margaritaville.
Mm-hmm. Yeah.
Jonathan, thanks for being with us.
It's a rough ask. Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.